On the night when China welcomed the New Year 2026, the sky above its megacities turned into a giant digital screen. Thousands of drones rose into the air simultaneously and began forming three-dimensional figures, light scenes, and dynamic images that looked as if a full-scale 3D display had been unfolded above the cities. For spectators, it appeared to be a festive show, but for engineers, military analysts, and AI specialists, it was a public demonstration of swarm drone control technologies at a level that just a few years ago was considered unattainable. It is important to understand the scale of what was happening. Controlling dozens of drones is one thing. Controlling thousands of machines within a single airspace is a task on the level of highly loaded distributed systems. Each drone in this show is an autonomous node with its own sensors, navigation, communication, and computing. It receives a general task from a central control system, but adjusts its trajectory in real time, avoids collisions, compensates for wind, turbulence, and signal interference. Essentially, we are witnessing swarm intelligence in action in the sky, a concept that underpins future autonomous systems, from cargo delivery to military unmanned platforms. The technological core of such shows represents a separate level of engineering. First, there is the positioning system. Drones must know their location with centimeter-level accuracy. Second, there are communication network protocols capable of transmitting commands and telemetry to thousands of devices without delay. Third, there are AI task distribution algorithms that determines where each drone flies in real time and what to do if one unit fails. If a single drone goes offline, the system instantly restructures the formation so that the audience does not even notice the loss of a pixel in the sky. It is also worth highlighting the synchronization of drones with fireworks and musical accompaniment. This is not just a spectacular visual effect, but a test of time coordination systems. All elements of the show, light, movement, pyrotechnics, sound, are managed as a unified real-time scenario. This requires computing power and planning algorithms that in the future could be applied to managing urban infrastructure, transport flows, and even power grids. In essence, such shows are public stress tests of smart control systems operating under extreme loads. But behind the beautiful exterior lies strategic meaning. China uses such events as a soft demonstration of technological strength. Instead of military parades, luminous drone swarms. Instead of showcasing weapons, showcasing control over highly complex autonomous systems in real time. This sends a signal to markets and governments. The technologies are scalable, refined, and ready for deployment in far more serious scenarios, including logistics, megacity monitoring, search and rescue operations, infrastructure management, and, in the long term, coordination of autonomous aerial fleets. It is also significant that China today is the global center of drone and drone component manufacturing. Large-scale shows serve as a showcase of the entire ecosystem, from batteries and motors to processors and computer vision systems. When thousands of drones operate synchronously without incidents, this proves not only the sophistication of the software, but also the reliability of the hardware, supply chains, and manufacturing processes. For investors and partners, this looks like a live advertisement for China's autonomous systems industry. Another layer of this story is social. Such shows gradually normalize the presence of drones in the skies above cities. People become accustomed to the idea that hundreds and thousands of autonomous machines may fly overhead, not as a threat, but as part of the urban environment. This is an important psychological factor. Today, it is a celebration. Tomorrow, it could be drones for delivery, traffic monitoring, event security, building inspections, and power line maintenance. Mass light shows are a form of soft preparation of society for an era when the sky will become as technologically saturated as the roads. Looking deeper, we are witnessing the birth of a new class of infrastructure, an aerial digital environment. AI-controlled drone swarms are prototypes of future systems in which thousands of autonomous machines will operate as a single organism. Today, they draw festive symbols in the sky. Tomorrow, they could deploy temporary communication networks in disaster zones, deliver medical supplies to hard-to-reach areas, and create temporary aerial platforms for surveillance and connectivity. The technological foundation is already being publicly demonstrated, simply in the form of a show. It is no coincidence that such events attract the attention of military analysts around the world. Swarm control is a key theme in future conflicts and security systems. When a country publicly demonstrates that it can coordinate thousands of autonomous devices within one airspace, it is perceived as a signal of technological maturity. Even if it currently looks like a celebration, the technological groundwork extends far beyond entertainment. In effect, China is presenting a model of the future in which mass autonomous systems become the norm, where AI manages complex processes in real time, and where swarm intelligence is used not only in laboratories, but in real, large-scale scenarios. That is why such shows matter, not only as cultural events, but as technological markers of an era. The world is gradually entering a phase in which thousands of machines act synchronously as a single digital organism. When we see the sky above a city transform into a giant living screen made of drones, it is worth remembering that this is not just a beautiful spectacle. It is a demonstration of what future infrastructure may look like: autonomous, distributed, AI-driven, and capable of scaling to levels that until recently seemed like science fiction. There is another important layer that usually remains behind the scenes in such shows: economics and data control. Each drone in such a performance generates a massive stream of telemetry: coordinates, speed, orientation, battery status, route deviations, and responses to interference and external factors. Altogether, thousands of drones create a data set on which swarm control algorithms are trained and improved. In essence, every festive show becomes a real-world training ground for AI under conditions as close as possible to operational reality: dense airspace, complex scenarios, strict synchronization requirements, and zero tolerance for errors. These data have strategic value. They accelerate the development of autonomous systems, improve navigation in complex environments, and increase resilience to communication failures and external interference. In the future, such datasets will become a competitive advantage for countries and companies that first learn to manage autonomous fleets at scale: aerial, ground, and maritime. When China regularly conducts such shows, it is not merely entertaining the public, but continuously refining its algorithms through real scenarios. The infrastructure aspect is also critical. Managing thousands of drones requires a reliable low-latency communication network, redundant channels, local computing nodes, and data processing centers near the event location. This is essentially a mini-model of future smart cities, where thousands of autonomous devices, drones, robots, transport systems, will be coordinated in real time. Such events demonstrate that the infrastructure is already capable of handling loads that until recently were considered experimental. Viewed globally, these demonstrations are elements of a technological race. The United States, Europe, and Japan are also developing drone swarms and autonomous systems, but China emphasizes scale and public visibility. It showcases not laboratory prototypes, but already refined, large-scale application scenarios. This creates an effect of technological pressure. Other countries are forced to accelerate their own programs to avoid falling behind in autonomous system management and AI coordination. Finally, there is the question of regulation and future rules. When thousands of drones simultaneously rise into the sky above a city, it requires special airspace management regulations, safety systems, and certification standards for autonomous flights. Such shows effectively push forward a new reality in which airspace becomes a digital infrastructure accessible to mass autonomous systems. The countries that are first to refine these rules in practice will gain an advantage in setting future standards for the global drone and autonomous aviation market. Ultimately, New Year drone shows in China are not just a beautiful tradition. They are a showcase of technology, a training ground for AI, a test of infrastructure for future smart cities, and an element of the global race in autonomous systems. Each such celebration is another step toward a world where thousands of machines in the sky, on land, and at sea operate as a single AI-controlled organism.